Show that the speed of the electron in the nth Bohr orbit in hydrogen is given by v sub n is equal to k sub e times e squared divided by n times h bar. Well, the first thing we're going to do is we're going to quantize angular momentum. And the way we do that is we take angular momentum, which is the mass times the velocity times the radius for circular orbits, and we set that equal to n times h bar, and h bar is simply Planck's constant divided by 2 pi. The next thing we're going to do is we're going to isolate the radius, so r is equal to n times h bar divided by mv. The second thing that we need to do is we need to set equal the centripetal force to the Coulomb force. And the centripetal force is mass times the centripetal acceleration, and the Coulomb force is the Coulomb constant times the charge of the first particle times the charge of the second particle, and we take the absolute value of both charges and we divide it by the radius squared. Next, we're going to expand some of these variables. The centripetal acceleration can be rewritten as v squared divided by r. And what we're going to do here is we're going to substitute in the values for Q. If you think of the hydrogen atom, there are only two particles in there. You have the proton and the electron, and those are both elementary particles, so we give that the symbol E. So we have E squared here. Even though the electron has a negative charge, we're taking the absolute value, so it'll be positive in this case. Afterwards, we're going to cancel out the r's on both sides, leaving us with mv squared is equal to k times e squared divided by r. We'll go ahead and cross multiply so that we get mv squared times r is equal to k times e squared. Next, we're going to substitute in this r value that we found here for this r in this second equation, and this is what it looks like when we go ahead and do that substitution. Afterwards, we're going to cancel the m and one of the v's here so that we're left with v times n times h bar is equal to k times e squared. Next, we'll go ahead and isolate the velocity so that we get v is equal to k times e squared over n times h bar. So now we have successfully proven what the question was asking us to prove.